One of the biggest regrets when learning mathematics is that after spending lots of time learning theories, one may be still unable to compute any single example. And I can tell you that this happens a lot when learning mathematics. And one of such examples is the computation of conditional expectations. Why do I say so? Let's first look at or recall the definition of conditional expectations. It states as follows. Let omega, script A, and P be a probability space, and script F be a sub-sigma algebra of A. Let X be an integrable random variable in this probability space. A random variable Y is called a conditional expectation of X, given F symbolically E of X given F, which refers to Y, if the following two conditions holds. First, Y is F measurable. Note that X, this random variable X, is A measurable, and now Y is required to be F measurable, where the F is a sigma algebra smaller than A. So this is the first condition. And second condition is that for any A in F, this smaller sigma algebra, this sub-sigma algebra, we have the expectation of X restricted to A is equal to the expectation of Y restricted to A. We multiply this X and Y by the indicator functions of A. And you know, this really just means the integration of those random variables over the domain A instead of the whole space. Now let us go back to the words I said at the beginning. Just look at the definition of the conditional expectation. Do you think you can really compute the conditional expectation just from this definition? Namely, if I give you a probability space and a sigma algebra and a sub-sigma algebra, and I give you an integrable random variable X, can you compute the conditional expectation of X given this sub-sigma algebra F? It's very hard from this definition to compute the concrete examples of conditional expectations. That is largely due to this axiom or condition number 2. This condition number 2 does not really give you how to construct this Y explicitly. And from the condition number 1, you only know that y is f measurable, which doesn't seem help much for giving the specific y. And if you have learned the proof of the existence of conditional expectations, which uses Radon-Nikodym derivatives, which also seem to be very abstract. And to be honest, when I first learned conditional expectations, I was also troubled a lot by how to compute any single example of conditional expectations. And now, in this video series, I will talk about how to compute conditional expectations when the subsigma algebra F is relatively special. It turns out when this F is a finite sigma algebra, namely a sigma algebra consisting only of finite many members, we'll have a very explicit formula for the conditional expectation of x given f. And I will show you what that formula is. So let me write down our goal for this video series. And let's get started.